Welcome to a new test and teardown video. This is a Radiometer Q-meter QM1F. This thing can measure, of course, Q, that is what it does, but it can also measure inductance and such. And as far as I understand, this is the oscillator frequency, where I think I am moving some coils around. External generator is that one. So if I go back to here, it's A, 50 to 160 kilohertz. So this is A. So that should be 100 kilohertz, because that is exactly what I want. So this is the capacity that I'm adding to the test point, and as long as this capacity plus in parallel with the 100 microhenry that I'm putting on right now is not in resonance with the 100 kilohertz, and I think I'm a factor, I don't know, 20 off or below the resonance point. So that means it shouldn't be a problem. And of course, this is the calibration of the capacity. It says picofarad down here. So, and this is a series resistor, a voltage divider, that is actually tuning or selecting the anode supply for the oscillator. And this is of course also the drive power, so we need to crank this up. I haven't yet figured out what exactly that is, but when we power this up, I should be able to figure this out. I think power is also using this meter as a current meter, so I can measure what is the current that I go pull through the test inductor. And then when I switch it between, I don't know, go down to measure instead of, I don't know exactly what is going on here, but I think measure is where I read the Q, and in shift I think I read the current, as far as I understood. It's a little bit unclear. And of course the on-off switch. What we need to do first before we power up anything, always check the rear side, and yes, it is correctly set for 220. Look at that. This is a modification for a new and modern power connector. I love it. That is a very, very nice upgrade. And what I also did, because I've learned from previous mistakes, I am measuring a DC resistance from the two outer terminals to chassis, and in this case I don't measure any ohms, so that means I can safely power this on. And I also measured 0 ohm from the center pin to chassis. That means when I'm using the correct power cord, I should be well protected against any kind of leak problems, and safety is always an issue when you're booting up old vintage equipment. So I warned everybody, now is the time we could lose power. You never know. Nothing. Oops. That can't be good. Oh, it took that long time. Now I got 10 watts. That is not a lot, but this one contains only, I think, 3 tubes. And one of them is a new visitor, there's a rectifier, and then there's a voltage regulator, so that's actually it. Ooh, power is 30 watts, 40 almost. That is not so... I don't know exactly what I expect. Well, let's see. There's an indication here, right? See? So this is the drive, yes, exactly. Ooh, slow-mo. Then, yeah, exactly, and then I get something on the Q. That is actually also what I So what is this doing exactly? How do I... So that means the generator is not working, or what? That is a little bit weird. I wanted 100 kilohertz. And then I wanted to measure I don't know what VTM0 is. Voltage something. And this is not reflected to this. Shift. Measure. Oh, damn it. I think we need to go back to the manual and figure out what exactly is going on here. I think I'm doing something wrong. Hey. It's not that easy. But the drive here is not affecting my Q factor, and nothing really seems to be doing that. How about if I try and... It's not dangerous in any way, right? Yeah, good. And then that is interesting. Okay. Measure. That can't be good. Either something is not working or I'm doing something fundamentally wrong. Because this is the capacity that was supposed to be in parallel with this one. So here I can of course add. Okay, we can try something more funny. Let's go to 1 megahertz. Because this should be 1 megahertz, right? So 1.1 megahertz, and then crank up the capacity to 200 picofarad, because this is 100 microhenry. So 100 microhenry, 200 picofarad, and 1.1 megahertz. Then we should have a resonant point, right? And then I see, yeah, look at that. I see a tiny little squeak. Squeakity squeakity. Add. It's not that bad, right? And what if I... Yeah, exactly. And it's also affected by this. So there is definitely resonance here. Haha, so that is great. Let's give it some more drive. Let's see if I can figure this out. It is always a lot more fun. See, there's definitely... I hit the sweet spot on this one. And this is also the 200. Yeah, and it's also reacting to that one. Great. And the power level. This is just the anode supply. It shouldn't really affect my Q. But this, I can just get whatever I want, right? So shift. Why do I put this? Hey. This is definitely not for dummies. The thing is, I know this inductor has a Q of about 100, or is it? No, it was only 60, right? Let me try and measure it. Here we go. I just put it on this meter. So at 100 kilohertz, I got 100 microhenry and about 68 in Q factor. That is what we are aiming for. Here's what I'm doing is, I looked in the schematic and it says there's a very, very small resistor between L low and ground, and it's pulling that current through this resistors or over this resistors, right? So that means I can just put my scope probe here, and what do you know? We can measure the oscillator frequencies, and we can also see the drive level is definitely adjustable. So that is good. And let's look at the frequency. So this is 160 kilohertz, and I'm in A, and it is 160. And of course I went to 100 here, and yeah, we are very close to 100. So this seems to be working. We got the generator going on. I'm of course going to check. This was A, so this is 160 to 500. Okay, so that is B here. What? 160 to, so that is 300, right? Yeah. Okay, let's A, B, and then let's go this way, right? So that is A again, but now it's 500 to 1600. Okay, so that will be 1 megahertz, right? And what do you know? Got 1 megahertz. And of course I need to go through all the different ranges just to see if it works. I think I actually figured this out. So now I set the frequency to 1 megahertz. So, and this is the area where this inductor, the 100 microhenry, will be in resonance with let's do 1.1. So this is 1.1, right? Then it should be in resonance with about 200. See what happens here? I think my frequency is a little bit off. But anyway, so here's what you do. You adjust the 0 at, you dial out of resonance, right? Far out of resonance. Fantastic. Now I'm out of resonance. Then I just dial for 0. See, can you see the meter now? So I go to find 0. Okay. Now I dial for resonance. Ooh, and look, when there's resonance, I can read the Q factor. 50, 60, 70. I think this is very close to what my new and modern meter said. How about that? And that was measured at this frequency. That is fantastic. So I think this thing actually works. I don't know about the drive current. It doesn't really matter if I go down at a much lower. Let's just put the dial down here, right? But I think you should have it at 1, right? So let's do the same. Dial it out of resonance. Oh yeah, you see? And then I put it for 0. Yep, 0, and then I dial it for resonance. See? I get a much lower resonance, and that is because my drive is not correct. So this one should be trimmed for 1. Ooh. This is difficult to do. Now it is done correctly, right? Because this is the multiplier. You see, it says actually here times Q, right? So if you're running with a very, very high Q, of course this is going to hammer out, but then you just put the drive current down, and this will also, so you can put down the current, and then you have a multiplying factor for the Q. See, now it all makes sense, right? So if I put this at 1, then the number here should be correct. Then of course I go way out of resonance, and then back to resonance, and then here we go, 50 something. Anyway, I think it actually really works. So now we're just gonna see how to open this, and I believe it's all the screws around the edge here. So this is what I'm gonna try and do. It was 29 watts when it was nicely up and running. There's a fun thing when I turn this on. The first few seconds I see absolutely no current draw from mains. Like 5, 6, 7 seconds later, then suddenly current starts to rise. This is really weird, and this bulb is not working, so I need to replace this as well. So let's try and open this. So this is the mains connector modification with actually a really cool. So this is a filter, and this is where the original mains connector was located. So that is a really great upgrade. And look at that. We got a rotten fuse. This I need to clean. So now we can look a little bit more closer inside the unit, and this will be the ground, and this is the current sense system and the injection from the oscillator unit. So all this is the oscillator. We need to open this, so there's a tube sticking out here. So this is the current injection, and the current sense just goes to the meter down here, and not a lot more really. So this is the amplifier tube for the measurement signals, and that is driving the other meter, the Q-meter, right? And yeah, see, I cleaned the fuse right and nice, and then I find another fuse down there is also corroded quite a lot, so I need to clean that one as well. So after that is cleaned, we can open and have a look in here. So now we're inside the oscillator. This case was made so you take out all of this by unscrewing here around the edge. So this is really, really cool for service. The adjustment capacitor is in 3 sections, and that will of course be for the high frequency parts of it, low frequency parts. And look how cool this is made. See, when let me see if I can, yeah, see? And then it goes like click. This roller here goes in, then click. And of course, because this is covering a really, really wide frequency range, everything here is made very different. And this is of course the highest frequency, and look at that, it's only one turn with a center tap even. See, one turn, center tap, and then we got 2 windings of some really, really thin wire going around, and it's here. So this is obviously some sort of an oscillator with some feedback, and they're all made exactly like that. So we got a few windings and a lot of windings, and we also got some adjustments possibilities and all that. It's really, really nicely made, this oscillator. And of course this will be the external input. It is just so fantastic. Oh, what I see here is a broken screw, I guess, or maybe this is just a steering tab. It's a little bit difficult to see. So they made a little mark here so you know how to align this. We also see some, okay, let me turn it the other way. Maybe we can see they marked something here, XX111. Isn't that funny? Now I also see some little, what is that? 515 picofarad. So somebody hand measured these and wrote on them. Also what I found, let me see if I can find it. I can't really find it, but there was a sticker on the detector tube. Also, this is not exactly the right schematic. I can't really find a schematic of the F version, because this looks like the anode of the tube is connected to the sense terminals here, and I don't really understand if this is correct or not. It was supposed to be the grid of the tube. So if this tube really what with grid on the top? I don't believe that. So, or maybe this is coupled in a completely different way, but I don't have the schematic of the F version, and this is an F version. I believe there's also a version with a nuvistor in the oscillator part, But anyway, I think we're done investigating this great unit. This will be the bottom side of the power supply, and they put the two voltage regulators far off each other so they're not going to heat up anything, because they can actually run a little bit hot. And we got some voltage drop resistors, filter capacitor. I think this filter capacitor maybe need a replacement, because I did see some ripple on the output, and but maybe it doesn't really matter if you got ripple, because you can't see it on the meter reading, so it could probably run off AC. The current injection and current measurement. So the red and the black wire here, that will be the current measurement output. And they say something about this is a temperature sensor element. So it works by measuring the temperature on this almost zero resistance. They should be connected on this super tiny little dot. I believe it's probably welded in this dot. So this is where the current flow, and then they measure the temperature in this tiny little dot, and this gives a voltage difference that is proportional to the current that actually heats up this piece of wire. That is a really weird way to do it, but this is how they did it. Let's just look at the voltage regulator. I really like the voltage regulator tubes because they just light up so much more compared to all the other tubes. See the other one down there? That's actually the rectifier. Isn't it just nice? Beautiful.